Good morning, students. Yesterday we have completed the 4 problems. So let me continue the next problem for NCERT. So after the completion of the 4 problems from the NCERT yesterday, so next 5th problem, problem number 5. Next 5th problem. Using the Bohr's model, calculate the speed of the electron, in hydrogen atom in the n equals to 1, 2 and 3 levels. This is first part of the problem. This is A and B part. Calculate the orbital period in each of these levels. So what we have to calculate? The speed of the electron in n equals to 1, 2 and 3, and also calculate the period of these levels, time period. Solution. We want to calculate the velocity. So we know that Vnth equals to c by n into 0.0073. Already we have given this one, right? Then radius Rnth equals to n square into R1, n square into 0.53 angstrom, right? Then we know that time period T equals to 2 pi r divided by V, right? Shall I go for that equation? Yes. So general equation which implies T1 equals to 2 pi r1 divided by V1, T2 equals to 2 pi r2 divided by V2. Now these are the equations to be calculated. First we go for the velocity, then I come across time period. For speed, n equals to 1, Vnth equals to c by n into 0.0073. Therefore, V1 equals to c by 1 into 0.0073. C is nothing but 3 into 10 to the power of 8 into 0.0073. देख लो, calculate करना. Calculate करते, is it 2.1? So 2.1 into 10 to the power of, I can write 6 meter per, that is nothing but 6 meter per second. पूरे इक्वेशन इधर से देखो, या 3 से मल्टीप्लाई करें, 3 3 9, 3 7 21, 2 zeros, total charge 0.021, 9 into 10 to the power of 8, 2 जगह हटा दिए 6. So shall I write after the multiplication? Confuse होता बोले तो और एक steps लिख दूँ मैं, right? कितना होता देखो, V1 equals to 0.0219 into 10 to the power of 8. 2 जगह हटाओ, 2.19 into 10 to the power of 6 meter per second. This is your first velocity. right? Then second velocity, v2 equals to v by, that is c by 2 into 0.0073, that is v2 equals to 3 into 10 to the power of 8 into 0.0073 divided by 2. उसको divided by 2 करे, then you get the answer. How much? This is 2.19 into 10 to the power of 6 divided by 2. v2 equals to 1.0, 2 8s are 16, 2 9s are 18, 5 10 to the power of 6 मीटर पर सेकेंड. सही है, कोई दिक्कत बात करने की ज़रूरत नहीं है. देख लो एक बार. देन v3, ऑलरेडी इक्वेशन इधर है वो, c by n. थर्ड वन, v3 equals to c by 3 into 0.0073. This is 3 into 10 to the power of 8 into 0.0073 divided by 3. इसका तो आपको मालूम है 2.19 into 10 to the power of 6 divided by 3. Then you can easily divide कर सकते हैं. That is nothing but 0.7. 2 7s are 3 7s are 21. Then 0. 3 3s are 9 into 10 to the power of 6. 7.3 into 10 to the power of 5 मीटर पर सेकेंड. लिख सकते हैं. 3 हो गए देखो. Then I go for time period. देख लो एक बार पूरा इक्वेशन इधर रखिए. सो दिस इज माय बेस. Now I go for next time period factors. Right? Shall I go for time period? Yes. निकाल दे तुम्हें इसे. For time period, T1 equals to 2 pi R1 divided by V1. So 2 into 3.14, R1 0.53 into 10 to the power of minus 10 divided by n equals to 1. So V1, what is the value of V1? 2.19 into 10 to the power of 6. अभी करे सो है, राइट? यहाँ पे R1 equals to, that is 0.53 angstrom, right? Right. Then I go for the time period for the first orbit, that is T1, 1.52 into 10 to the power, and after solving this one, 1.52 into 10 to the power of minus 16 second. ये ऊपर चला जाता है, minus 16 हो जाता है, right? Then T2, 2 pi R2 divided by V2, 2 into 3.14. So what is R2? R2 equals to 2 square 4. 4 into 0.53 into 10 to the power of minus 10 divided by, what is that? V2. Already आपको मालूम है that V2 is nothing but, कितना था आपके पास? ऑलरेडी वह कैलकुलेटेड V2 करे थे ना. सो Let me go for V2 1.095 into 10 to the power of 6. सही है, करे थे ना अभी. अब उसको कैंसलेशन करे, do the necessary cancellation, we get 1.212 directly 1.216 into 10 to the power of minus 15 second, right? अब T3 को जा सकते हो वैसे ही. Then T3 2 pi R3 by V3. This is 2 into 3.14. यहाँ पे लिख सकता हूँ मैं 2 into 3.14. What is R2? R3 3 square 9. 9 into 0.53 into 10 to the power of minus 10. V3 निकाले थे. What is the value for V3? That is nothing but 7.3 into 10 to the power of 5. अभी करे थे ना. When you go for that cancellation, this becomes what? 4.1 into 10 to the power of minus 15 seconds. These are the answers. ये कैलकुलेटर से कर सकते हैं आराम से, right? इससे हम वेलोसिटी कैलकुलेट कर रहे हैं. इससे हम रेस्पेक्टिव टाइम पीरियड T1 करस्पॉन्डिंग R1 V1, T2 करस्पॉन्डिंग R2 V2. एक बार देख लो पूरा अच्छी तरह से. Shall I go for the next? 6 प्रॉब्लम जा सकता हूँ मैं. एक बार पूरा ग्लांस करो अच्छी तरह से. पूरा फार्मूला इधर रखे. सो यही फार्मूला मैं बेस बना चुका हूँ मैं. खाली डाटा सब्स्टिट्यूट करे. सो then let me go for 6th problem. 6th problem क्या है देखो. 6th problem so what is the 6th one? देख लीजिए. 6th problem. The radius of the innermost electron orbit. The radius of the innermost electron orbit of hydrogen atom is 0.53 angstrom. What are the radii of the n equals to 2 and n equals to 3 orbits? Right? Question mark. Innermost orbits, first orbital radius this way. You want to calculate the radius of the second orbit and third orbit. Already आपके पास है solution. Given the radius of the first orbit 0.53 angstrom. What is R2? What is R3? We know that अभी का रेशो है Rn equals to n square into R1. n square into 0.53 angstrom. Therefore, first one R2 equals to 2 square into 0.53 angstrom. 4 into 0.53 angstrom. What is R2? 4 3s are 12, 4 5s are 20, 20 plus 1, 21. 2.12 angstrom. Right? Minus 10 भी लिख सकते हैं. Angstrom is nothing but minus 10 meter. This is the 2.12 into 10 to the power of minus 10 meter. लिख सकते हैं? Yes. Second one, R3 is equals to 3 square into 0.53 angstrom. R3 equals to 9 into 0.53 angstrom. What is that value? R3. 9 3 is 27. 2. 45 plus 2, 47. 4.77 angstrom or 4.77 into 10 to the power of minus 10 meter. Is it clear? देख लो एक बार. So second orbital radius is 2.12 angstrom and third orbital radius is 4.73 angstrom. 4.77 angstrom. So yeah. Then shall I go for seventh problem? Yes. Let me go for seventh problem. निकाल दूँ मैं इससे? Yes. Problem number 7. I go for seventh problem. What the seventh problem tells? A 12.5 electron volt electron beam is used. A 12.5 electron volt electron beam is used. क्या देखो? A 12.5 electron volt electron beam is used to bombard gaseous hydrogen at room temperature. What series of wavelength will be emitted? Right? You want to calculate the wavelength. He has given the energy. Solution. क्या क्या दिया है देखो? Given energy 12.5 electron volt, 12.5 1 electron volt. What is that? 1 electron volt 1.6 into 10 to the power of minus 19 joules. Right? Then our aim is to calculate lambda. We know that E equals to h nu, nu equals to c by lambda, lambda equals to sc by E. Substitute करो. 6.625 into 10 to the power of minus 34. Planck's constant है. Velocity of the light or photon 3 into 10 to the power of 8 divided by energy 12.5 into 1.6 into 10 to the power of minus 19. Then do the necessary cancellation, you get the answer. If you approach the calculator, calculator को सहूलत तो है आपको. अगर CET रहता बोले तो ट्रिक्स दे देते. अब यहाँ पे ट्रिक्स क्या है? इसको 1.5 कंसिडर करें, कैंसिल होता है, 2 सा हो जाता. Right? So your answer is lambda equals to 993 into 10 to the power of minus 10, 993 angstrom. Right? So for Lyman series, वेवलेंथ रेंज आपको दे सो LBP BP और इसका अल्ट्रावायलेट, उसका रीजन क्या है? 912 एंगस्ट्रॉम टू 1216 एंगस्ट्रॉम. Is your 993 under this देयरफॉर ये हमारा लाइमन सीरीज का वेवलेंथ सीरीज है. देयरफॉर लैम्डा इक्वल्स टू 993 एंगस्ट्रॉम is comes under in what? Lyman series. Is under Lyman series. Right? That is ultraviolet region. ये अल्ट्रावायलेट का रेंज है. वो आपका जो whatever the wavelength is emitted, that is comes under in what? Lyman series, ultraviolet region. राइट, एक बार देख लो पूरा अच्छी तरह से. उसका रेंज आप लोगों को इलेक्ट्रोमैग्नेटिक वेव्स में मिल जाता है, वहाँ पे भी हिंट है. Then shall I go for the next one? निकाल दो इसे. Yes. I go for 8th problem. Eighth problem. What is telling now? Eighth one. In accordance with the Bohr's model, in accordance with the Bohr's model, find the quantum number. Find the quantum number that characterizes the Earth's revolution around the sun in an orbit of radius 1.5 into 10 to the power of 11 meter with orbital speed 3 into 10 to the power of 4 meter per second. The mass of the Earth. Now this is the problem he has given data. Our aim is to calculate the principal quantum number. Right? When the electron is revolving around the nucleus, it possesses angular momentum. Right? So our planetary system is considered to be atomic model concept. So when the planets are revolving around the sun by keeping sun as a focus, there is angular momentum. That angular momentum concept is applied to the Bohr's quantization theory. Solution. According to the Bohr's quantization rule, angular momentum mvr equals an integral multiple of h divided by 2 pi. We need n mvr into 2 pi divided by h. So यहाँ पे मास दिया सो है substitute करो, n equals to mass 6 into 10 to the power of 24, velocity 3 into 10 to the power of 4, radius 1.5 into 10 to the power of 11 to 3.14. What is the Planck's constant? 6.625 into 10 to the power minus 34. Right? By solving these factors, we get n equals to 2.6 in 10 to the power of 72. That is nothing but 74. This is our number. This number is too large. We consider 2.6. That 2.6 is nearly equals to what? 3. So electron should jump for hydrogen from ground state, that is nothing but Bohr's atom model is meant for hydrogen atom. The electrons are available in the hydrogen, that is in the ground state, that is nothing but n equals 1. It can jump to the any higher orbit. What is that highest orbit here? We consider this number, that is nothing but 2.6 is nearly equals to what? 3. So this number is very large. Large number. 10 to the power 74. Show those 2.6, that is nearly equals to 3. Hence we can say that electron would jump. Electron would jump from n equals to 1 to n equals to 3. Therefore, nth orbital energy equals to minus 13.6 divided by n square electron volt. Right? This is, that is nothing but third orbital, E3 na? E3 minus 1.51 electron volt. .54 something आता है, 1.54 something, right? 1.5 लिख सकते हैं आप लोग. The electron is jumping from third orbit to the first, so belongs to Lyman series. Belongs to Lyman series because n equals to 1. Right? एक बार पूरा देख लो. Right? Is it clear? Yes. Then after this, समझ में आ गया? 2.6 into 10 to the power of 74, that is a large number. 2.6, that is nothing but nearly equals to 3. We consider that number. So the electron should jump from higher orbit, third to the first, that is nothing but the Lyman series. What is the energy possessed in the third orbit? Minus 1.54 electron volt, that is simply minus 1.5 electron volt. Right? और एक प्रॉब्लम इधर 9th डाल दे तुम्हें. 9th, What is the shortest and longest wavelength? What is the shortest and longest wavelength? Wavelength present in the Balmer series of spectral lines. कौन सा है देखो, for Balmer series n1 equals to 2, n1 equals to 1, that is Lyman series, n1 equals to 2, that is Balmer series, n1 equals to 3, Paschen series, n1 equals to 4, bracket series, n1 equals to 5, Fund series, right? Then number 1, for shortest wavelength lambda minimum, for shortest wavelength lambda equals to lambda minimum, where n2 equals to infinity. Therefore, lambda minimum is equals to n1 square divided by r. ऑलरेडी हमारे पास है n1 square, that is nothing but 2 square, r 1.097 into 10 to the power of 7. This is 4 divided by 1.097. This is 10 to the power of minus 7 meter. So lambda minimum कितना right, 4 divided by 1.1 ले सकते इसको, right? This is our answer. कैलकुलेटर ले इसको डिवाइड करके आंसर रख दो, right? That is the 3.8 or 3.9 something, right? कैलकुलेटर रहता आप लोगों को डिवाइड करके मिनिमम. अब मैक्सिमम वेवलेंथ, what is the condition for maximum wavelength? n2 equals to n1 plus 1, right? देख लो इसे. Shall I go for maximum wavelength concept? For maximum wavelength, for lambda maximum, n2 equals to n1 plus 1, that is nothing but 2 plus 1, 3. Therefore, we know that 1 by lambda equals to r 1 by n1 square minus 1 by n2 square. So 1 by lambda maximum is equals to r 1 by 2 square minus 1 by 3 square, right? This is 1 by lambda maximum is equals to r 1 by 4 minus 1 by 9. So 9 minus 4, this is 5r by 36. Is it clear? Yes. 9 minus 4 is 5, 5 into r, 5r. Therefore, lambda maximum is equals to 36 divided by 5r. 36 divided by 5, 1.097 into 10 to the power of minus, that is plus 7. Lambda maximum equals to 36 divided by 35, 48, 5.485 ऊपर लेके 10 to the power of minus 7 meter. This is your answer. right? Now these are the maximum wavelength and minimum wavelength for respect to which series? Balmer series. इसी तरह आप कौन सा भी पूछो तो आप डाल सकते हैं, प्रोसीजर मालूम रहना बस. राइट, ये तो आपके पूरे एनसीईआरटी के प्रॉब्लम्स हो गए. देन वन मोर क्लास आई एम गो फॉर द जनरल प्रॉब्लम्स. सो मैक्सिमम प्रॉब्लम्स विच आर आस्क्ड इन द एग्जामिनेशन सेक्शन जो है, एक प्रॉब्लम कर देता और एक क्लास में प्रॉब्लम हो जाता. देन दैट मेक्स एंड ऑफ द व्हाट, द टॉपिक विथ थ्योरेटिकल सेक्शन एंड न्यूमेरिकल सेक्शंस. इज इट क्लियर? यस. सो लेट मी कंटिन्यू इन द नेक्स्ट क्लास. दैट इज़ नथिंग बट एग्जामिनेशन सेक्शन के हायर वर्शन प्रॉब्लम्स को सॉल्व करके. एनसीईआरटी के जो 9 थे पूरे 9 हो गए. देन वी गो फॉर जनरल सेक्शन प्रॉब्लम्स और एग्जाम सेक्शन प्रॉब्लम्स. इज इट क्लियर? Yes. Let me continue the next class. Thank you.